Sand casting is one of the most versatile and widely used metal casting processes in the manufacturing industry, accounting for a significant portion of total casting tonnage. The core of this process is to pour molten metal into a mold cavity formed from a compacted sand mixture. The metal solidifies and the sand mold is broken away to reveal the finished part. This process is called the shake-up process. The success of this process depends on the creation of pattern, which is the physical replica of the object. In this experiment, polystyrene is used to make the replica. It will create a negative impression within the flask, which is a specialized frame which will be filled with sand and binding agent. Engineers and designers favor the sand casting for several reasons, which include material versatility, so it can accommodate almost any alloy, including iron, steel, aluminum, and bronze. It can also produce components ranging from small hardware pieces to massive engine block weighing a ton. Finally, tooling costs are generally lower than those for die casting, making it ideal for low to medium volume production and prototyping.
Sand casting is a versatile manufacturing process that uses expandable sand mold to produce metal components of almost any size or shape. So it is widely used in industry like automotive and aerospace because it can handle both ferrous and non-ferrous metals while remaining cost effective. Then the process starts by creating a mold from silica sand, which mix with a binder and then give it strength and thermal stability while allowing gases to escape. So molten metal is then poured into the mold cavity, replicating the desired design, even complex internal features. Okay, so then the temperature control is crucial during melting in order to keep the metal fluid and free from the defects. So once poured, careful cooling also is important because it can ensure the directional solidification and to prevent the shrinkage and creating a strong uniform grain structures. So in short, sandcasting transforms design into functional parts efficiently and reliably, making it an essential process in modern manufacturing.
And now for the procedure, the experiment began with the preparation of the molding sand by thoroughly mixing silica sand with an appropriate amount of binder to achieve sufficient strength and permeability. The polystyrene pattern was placed at the center of the box of, of the sand molding box, after which the prepared sand was gradually filled and compacted using a ramming tool to ensure uniform density. Once the jet was complete, the coke was positioned on top and filled with sand to complete the mold assembly. The pattern was then carefully placed the pattern was then carefully removed to form a clean mold cavity. After the mold cavity was formed, a thin and uniform layer of carbon was applied onto cavity surface using a carbon spray machine. This step was carried out to improve the surface finish of the final casting and to reduce metal penetration and sand burn on during pouring. The cope and drap were then aligned and clamped securely to prevent misalignment or leakage when molten metal was introduced into the mold. In the metal melting stage, aluminum ingots were placed inside a crucible and heated in an electric furnace until fully molten. Proper personal protective equipment was worn throughout the process to ensure our safety. The molten aluminum was then carefully transferred using tongs and a pouring ladle and poured steadily into the mold cavity. After allowing sufficient time for solidification and cooling under ambient conditions, the sand mold was broken and the aluminum casting was removed for inspection.
For this experiment, aluminum was used as the casting material and successfully melted before being poured into the prepared sand mold. The final casting produced generally matched the intended pattern shape. The circular profile and internal features were clearly formed, indicating that the mold cavity was properly prepared and that the molten aluminum was able to flow and fill the mold completely. However, the surface finish of the casting was rough and uneven. This is mainly due to the use of coarse molding, sand, and limited sand compaction, which is a common characteristic of basic and sand casting process. Flash was observed along the parting line of the mold, and this occurred due to the slight misalignment between the cope and drag section of insufficient clamping during pouring. In addition, some rounding of sharp edges was observed, particularly at thinner section, which may be caused by a relatively high pouring temperature and erosion of the sand mold by the molten aluminum. Overall, the experiment successfully demonstrated the fundamental principle of aluminum melting sand casting. The defects observed are typical of laboratory scale sand casting and highlight the importance of mold preparation, alignment, and pouring control in improving casting quality.
In conclusion, the experiment successfully demonstrated the fundamental principle and practical challenges of the cell casting processes by creating a mold cavity and pouring the molten metal into the mold cavity. The relationship between pattern design and final geometry can be observed. The property of the sand which are very critical, specifically its permeability and strength, are to the integrity of the final casting. While the experiment resulted in a solid part, it also provided valuable insight into the common variables that affect quality. Observation made during the shakeout phase show how the gating system and riser placement influence the solidification of the metal. Surface irregularity or slight dimensional deviation in the experiment show the importance of proper sand compaction and moisture control during within the green sand.